Hi students, our lesson today is on exponential functions. Alright, so an exponential function is a function where the variable is part of it's an exponential function, right? Exponent. So the variable is part of the exponent. Alright, if b is greater than 1, the function is an exponential increasing, exponential growth. And is increasing. If b is less than 1, the function is an exponential. So opposite of growth is decay and is decreasing. All right, an asymptote, very important vocabulary word for exponential functions. An asymptote is a line in which the graph gets closer to but never touches. And we'll see examples of what that means in some of these problems that we go over. All right, classify an exponential growth or decay function graph and then identify the key characteristics. All right, so we have this exponential function, right? It's an exponential function because our variable is located in the exponent. All right, so let's just say we have x. Let's go ahead and just use the numbers 0, 1, 2, 3, 4. All right. So with 0, right, that just means we plug in 0 into our x. And then as you guys know, anything to the 0 power is just 1. All right. If x is equal to 1, that's just, 2 to the first power. And that's just 2. All right. If x is equal to 2, that's just 2 to the second power, which is just 4. 2 to the third power is equal to 8. And then 4, that's 2 to the fourth power, which is just equal to 16. All right, so first let's go ahead and classify the function before we go ahead and graph this on the right. We know that this is going to be our b right here. So our rule is if b is greater than 1, our function is an exponential growth. All right, so it's going to be an exponential growth. And then growth is the same thing as increasing. All right, so let's go ahead and use these values that we have over here to go ahead and graph. We have 0, 1. So that's going to be that point right there. 2, 4. Oh, we didn't graph 1. Sorry. 1, 2 as well. And then 3, 8. So 4, 16 is going to be a little bit off of our graph. All right, so we don't have to go ahead and graph that. But for graphing, especially on the homework for tonight, all I want you guys is just to have the general shape. I want some points like as we did here, but what I mean by the general shape is, this is how it's going to look like. All right, so the general shape, right? As we pass the 0, it starts to decrease, but it never touches 0. And then we'll see in future examples how this asymptote, right? This is our asymptote. Let me just write that. Asymptote. The end of this graph, right? Asymptote is a line in which the graph gets closer to but never touches. So it never touches zero. It gets closer and closer and closer to zero, but it never touches. So asymptote right down here, y is equal to 0. All right, the domain. Domain, remember, furthest left to the furthest right. Furthest left is negative infinity. Furthest right is positive infinity. All right, range from the bottom to the top. So the lowest our graph goes is 0. So it never touches 0, right? So we use a parentheses because it never touches 0. And then the highest our graph goes, well, it keeps on going, doesn't stop. So infinity. All right, then our y-intercept. That's wherever our graph crosses the y-intercept. That's what is that? 0, 1. All right, so as we do more examples, you'll get used to what I mean by the general shape of our graph. But yeah, this is how it looks like, generally speaking. All right, moving on. Number 2, we have 1/4 raised to the x power. All right, so if b is less than 1, right? This is our b right here. If b is less than 1, we know it's going to be exponentially decreasing. All right, so let's just go ahead and use the same numbers that we did before. Actually, I'm going to start off with -1, 0, 1, 2, and 3. And then -1, so that's just 1/4 raised to the negative first power. And if you guys remember from our exponent rules, remember if we have a fraction and we have it raised to the negative power, that's just the same as flipping that fraction over. So -1, that's just going to be 4. All right, 0. So anything raised to the 0 power, 1/4 raised to the 0 power, that's just 1. All right, 1/4 to the first power, that's just itself. All right, 1/4 raised to the second power, that's literally 1/4 multiplied by 1/4, which is just 1/16. And then this is going to get more smaller and smaller. So that's just 1/4 to the third power. That's just 1/4 multiplied by 1/4 multiplied by 1/4. So that's just 1/64. All right, so before we go ahead and graph this, let's just go ahead and classify the function by circling what applies. We know that since our b is less than 1, it's going to be exponential decay. And then that's the same thing as decreasing. All right, going ahead and graphing, let's just go ahead and graph our points first that we have -1, 4. That's going to be right there. All right, 0, 1, that's going to be right there. And then let's see, 1, 1/4. And then honestly, it's just going to get, like, it's hard to graph these points because, I mean, our points aren't that small. Yeah, so the difference between 1/16 and 1/64th, like, that's hard to see on the graph because our scale is so, our scale isn't that small, right? Because we go by ones. Yeah, but like I said before, I just need the general shape of our graph, which is going to look like this. So as long as you have the y-intercept and it decreasing and the asymptote, that's all you need. So let's just go ahead and connect these dots like this. And then once again, as long as you know that it's exponentially decreasing, right? I just need the general shape of our graph. That's fine. All right, so the domain, negative infinity, comma, infinity. Furthest left our graph goes, the furthest right our graph goes. All right, the range. What's the range of our graph? Well, the bottom, which is 0, all the way to the top, which is positive infinity. So why is our range 0? Because remember our asymptote. Our asymptote is y is equal to 0, right? This is our line, right? This is our line where the graph looks like it touches, but it doesn't. So I know like on my graph, it looks like it touches 0, but technically it never does. All right, then y-intercept, that's just going to be 0, comma 1, or y-intercept right there. All right, question number 3. This is our b. So we know our b is greater than 1, so it's going to be exponential growth. And it's going to be increasing, right? As we go from left to right, it's going to be increasing. Okay, so let's use, let's just stick with our same x values, -1, 0, 1, 2, and 3. All right, so if I plug in -1 for x, that'll be 1/3. Let's try to do this on the side. 3 to the negative first power, and then I have to add 1. And then you guys know that, remember, when we have something to the negative exponent, we bring it down to the denominator. All right, so 1/3 plus 1, that gives us 4/3. All right, 3 to the 0 power plus 1. All right, x is 0. 3 to the 0 power is 1. 1 plus 1 is 2. All right, number 1. Let me just try to write these out so you guys aren't confused by what I'm talking about. 3 to the first power plus 1. Well, 3 to the first power is 3. And then 3 plus 1 gives us 4. All right, 3 to the second power plus 1. That's equal to 9 plus 1. So that gives us 10. That's already looking at off our graph. So we can go ahead and stop there. This is going to be 3 to the third power, which is 27, plus 1, which is 28. But we won't need that because we don't have 28 on our graph. Our graph only goes up to 8. All right, so let's just work with what we got here. -1, comma 4/3. That's going to be maybe right around there. All right, 0, comma 2. 1, comma 4. 2, comma 10. Let me just graph it like right there. It's about there. And then, yeah, 3, comma 28. Like I said before, we don't need to graph that. All right, so if we are thinking about our general shape of our graph, right, it's exponential growth and it's increasing. All right, so how does this change with our asymptote, though? So with our asymptote, this is going to be our asymptote, right? Anytime you have a plus 1 or minus something, that's always going to be your asymptote. All right, so let's go back on to our other problems. Right, so do we see how technically we could have like plus 0 over here? So that's where our asymptote is, all right? Y is equal to 0. Same thing with question number 2. Technically, we could have a plus 0 out here. So that's how our asymptote was y is equal to 0, right? Our asymptote down here y is equal to 0. But now we have our plus 1. So this is our y asymptote. So what does that mean? Well, in writing it as a line, that's going to be y is equal to 1. But more importantly, on our graph is going to approach 1 but never touch it. So this is how it's going to look like on a graph. All right, yeah. So once again, instead of approaching 0, it approaches 1. And it's exponentially increasing. All right, domain. Furthest left our graph goes is negative infinity. Furthest right our graph goes is positive infinity. Range. Furthest down our graph goes is 1, right? The lowest our graph goes is 1. That changes with that asymptote. The highest our graph goes is positive infinity. And our y-intercept 0, 2. All right, last problem. We have f of x is equal to 3 multiplied by 1/2 x. All right, so this 3 is not our b. We'll learn that later. This is called our a value. But anyways, this is our b value, right? 1/2. So since 1/2 is less than 1, we know it's going to be an exponential decay. And it's going to be decreasing. All right, so let's go ahead and use our values that we did before. -1. Yeah, let's just stick with -1. Yeah, there we go. All right, so this would be -1, so that'd be 3 multiplied by 1/2 to the negative first power. Right, remember, this is the same thing as, let me just write it out here actually so we don't, I'm going to write it on the side. All right, so 3 multiplied by 1/2 to the negative first power. That's the same thing as, remember, you would flip the fraction if it's a negative exponent. So that's 3 multiplied by 2/1. And then you guys know that's 6. All right, now we have 3 multiplied by 1/2 to the 0 power. So 1/2 to the 0 power is just 1. So this is just the same thing as 3 times 1, which is just equal to 3. All right, 3 multiplied by 1/2 to the first power, that's just 3 times 1/2. All right, so we can just write that out as 3/2, 3/2. All right, 3 multiplied by 1/2 to the second power, that's just 3 multiplied by 1/4. Right, 1/2 squared is just 1/4. So that's going to be 3/4. And then let's see, 3 multiplied by 1/2 to the third power. That's just 3 multiplied by, 2 times 2 times 2 is 8. So 3 multiplied by 1/8. And that's going to be 3/8. All right, going ahead and graphing this. All right, so -1, 6, 0, 3, 1, 3/2. That'll be right around here. 2 comma 3 fourths, and then 3 comma 3 eighths. All right, so this graph, it looks like it's matching what I said before. Remember, this plus 0, we can technically think of, that's our asymptote, right? So our asymptote is y is equal to 0. And it's following that the pattern that we thought of, right? It's never going to touch 0. That looks exactly what we're doing. And we know it's decreasing. So yeah, that's our graph. Once again, I know it's when we're drawing this graph, it's hard to draw a graph where it like maybe inc- goes to 0 but never touches. So yeah, once again, on my graphs, technically it's not supposed to be touching, but it's hard to sort of draw that. All right, domain negative infinity comma infinity. Our range, the lowest our graph goes is 0. Once again, parentheses because it never touches it. Highest our graph goes is infinity. And our y-intercept is at 0 comma 3. Right, y-intercept right there.